right, so in today's lecture, we are going to complete your Trendsetter Part 2 table. And I've already filled in my notes for the highlighted columns. So as you kind of progress along, you can pause the video and double check what you have completed in the highlighted columns matches mine, and if not, please correct your table. This will be your notes for Chapter 5, Section 2. What we want to focus on are valence electrons. And valence electrons are important because these are the electrons that participate in bonding. All right, so let's start. And I picked out elements that were in your Trendsetter Part 1 activity. So element MM is actually sodium on our periodic table. And when we talk about group configuration, we're talking about electron configuration. Now, I'm going to put an N in place of the energy level because N depends upon the period you're in. But all the elements in group 1 have electrons in sublevel S, and they have 1 electron in sublevel S. And so for valence electrons, it would be the highest energy level. So that would be N. It would be the sublevel S and P for that energy level. And sodium's an S block element, so there's only S. And it's how many electrons are in that S. And there's 1. Now, what we're going to want to do at some point is take and be able to connect electron dot diagrams of the elements to show bonding. So we need to know how to draw the elements electron dot diagram. So you start by drawing the symbol of the element. So sodium symbol is Na. And that symbol represents the following. It represents the nucleus, so all the protons and neutrons, and it represents all the inner shell electrons. So in other words, the electrons that are not part of the valence shell. And then we're going to put dots around the symbol, and you put however many dots as there are valence electrons. And so there's just 1. Now we kind of need to write a rule. So here's my rule for group 1. For group 1, the group number is equal to the number of valence electrons. Okay, let's look at the next group. So magnesium's in group 2 of the periodic table. So again, I'm going to use N to represent the energy level. Group 2 is an S block element, and it is the second element in the S block. So the valence electrons for group 2 is 2. So again, my rule here for group 2 is that the group number is going to be equal to the number of valence electrons. And so if we're going to write the electron dot diagram, we're going to write the symbol of the element. So magnesium symbol is Mg. Okay. And it's going to have 2 dots. Now here's what we want to do. Imagine that there's a box that's drawn around the symbol. So there are 4 sides. You can only have 1 dot on each side before you can have a pair of dots. All right, so kind of think of it this way. You have 8 friends, and you have a bag full of candy, and you need to sort it all out. So the easiest way would be to give each friend 1 piece of candy before you give them a second. So the same is true here. We're going to give each side a dot before we can give it a second dot. All right, let's go on to the next element in our table. So the next element in our table is aluminum. And so for aluminum, it's so that it has electrons that are in the S. So again, N is representing the energy level. And it has valence electrons in the P. and it's the 13th group, so that means it has 1 electron in P. So if I add these together, there are 3 valence electrons. And so for group 13, there's a rule for determining valence electrons. So in this case, the way we determine the number of valence electrons is that we're going to take the group number and we're going to subtract 10. So if I'm drawing the electron dot diagram, we're going to write the symbol of the element with its 3 dots. And remember, we're going to put 1 dot on each side. All right, silicon is in group 14 of the periodic table. So its group electron configuration would be, again, it has a full S sublevel. And in P, it's group 14, so it has 2 electrons in P. So we're going to add the electrons in S and P together to get 4. And again, here's my rule for determining valence electrons for group 14. So if I take the group number and I subtract 10, that's going to give me my number of valence electrons. So we're going to write the symbol for silicon, which is Si, and then it's going to have 4 dots. All right. The next element in our table is phosphorus. So it has electrons that are in valence electrons that are in S. So there are 2 of those. And it's in the 15th group, so that means that there are 3 electrons in P. And so if we add the electrons in S and P together, we're going to get 5. And again, if I'm trying to determine the number of valence electrons, we're going to take the group number and we're going to subtract 10. For my electron dot diagram, we're going to write the symbol for phosphorus, which is the P, and it's going to have 5 valence electrons. 1, 2, 3, 4. And then finally, we can put a pair of dots. So there are 5 dots surrounding phosphorus. All right, so we're still in that 3rd period of the periodic table. We're moving over to the next group, so group 16. So it has 2 electrons in S, and it's the 4th group in the P block, so there's going to be 4 electrons in P. And if we add them together, we get 6 valence electrons. And again, if I want an easy rule for valence electrons, we're going to take the group number and we're going to subtract 10. So the electron dot diagram, we're going to write the symbol for sulfur, and it's going to have 6 dots. 1, 2, 3, 4, 5, 6. So this will have 2 single dots and 2 pairs of dots. We're going to move over to the next group. So we have 2 electrons in S, and group 17 has 5 electrons in P. So if I add the S and P together, we're going to get 7 valence electrons. And again, I can determine the number of valence electrons by taking the group number and subtracting 10. So for the electron dot diagram, we'd write the symbol for chlorine, and it's going to have 7 dots. So it's going to have 3 pairs and 1 single dot. Okay, and then the last group is argon. So it also has 2 electrons in S, and it's going to have 6 electrons in P. So if I add S and P together, we're going to get 8 valence electrons. And again, my simplified rule for determining valence electrons for group 18 is we're going to take the group number and we're going to subtract 10 from it. Now, 8 is the maximum number of valence electrons an element can have. So this is why the noble gases are unreactive, because they have a complete valence shell. We're going to write the symbol for argon, and we're going to put its 8 electrons. So here we're going to have 4 pairs of dots. Okay. Now, all noble gases have a complete valence shell, but helium is an S block element. So the number of total valence electrons it's going to need is going to vary from the rest of the noble gases, but it's still going to be a complete valence shell. So helium's complete valence shell is 1s2, and so it has only 2 valence electrons. So there's really just memorizing how many valence electrons helium has. There's no rule here. So we would write the symbol for helium with its 2 single dots. Okay. All right, the next part of our table, we're going to talk about hydrogen. Okay. So hydrogen is a nonmetal, so that makes it different from the other elements in group 1. And it doesn't have the other properties of group 1. So the only thing they have in common is their number of valence electrons. Okay. So hydrogen's electron configuration we should know is 1s1. And this one tells me it has just 1 valence electron. And so its electron dot diagram would be its symbol with its 1 dot. Now, for the remaining elements in the table, we're not going to discuss valence electrons, so you won't be required to know valence electrons for transition elements, the lanthanides or actinides, okay, because these can vary. All right, but we can talk about group configuration. So we know from our discussion of electron configuration, if I take the period and I subtract 1, that would give me the energy level for the D block. And for the lanthanides and actinides, if I take the period number and I subtract 2, this would give me the energy level for the F block. All right, so now you have all of the notes for your table for Trendsetter Part 2.